Hi, I'm Scott. Welcome to this video. As the title says, CAN bus on the cheap, USBee AX Pro clone plus Pulseview. In this video, I'm going to explain how you can cheaply monitor what's happening on the CAN bus. This can be useful in a number of different ways, and I'll leave that up to you, but here's how to do it. Okay, so to see the CAN bus on our computer, what we're going to need is a logic analyzer. Now, a place called Deal Extreme, which is I believe based in China, they sell a unit called a USBee AX Pro. Now, my understanding, this is a clone of an old logic analyzer made by another company. They're really good value. You can see there $9.35, and that's including free shipping. I'm based in New Zealand, but I believe they ship most of the world for free. And it comes with some leads to plug into there, which you're going to connect up to whatever you want to see, in our case the CAN bus, and then a USB cable to plug into your laptop or PC. Now, if we scroll down the page here, we can see that it shows some screenshots of some software. Now, I believe this software is the software that you get when you buy the proper logic analyzer from the company that originally made it. Personally, I don't feel comfortable with using that. You may, and that's up to you, but there is an alternative which we're going to talk about next. Okay, so that alternative to the proprietary software is a program called Pulseview. Now, this runs it's based on something called SIGROC that's been developed by open source developers, and Pulseview is basically logic analyzer software for free that you can use. You can download it, and it runs on a variety of operating systems. I downloaded the Windows version and installed that, and with a bit of fiddling managed to get it to display what's happening on the CAN bus. So I'll show you how to do that now. Okay, so now that we've got our USBee AX Pro, we've got our multicolored ribbon cable that came with it, we've got our USB cable. What we want to know is how to hook up this to the CAN bus. So you'll see on top of the USBee AX Pro that there's an image showing the pin out. You'll see there's a couple of ground pins. Now, whether this is the proper way to do things, I couldn't tell you, but this is what works. If you take one of the ground pins of here and connect it to the ground of the device that's transmitting or receiving the CAN bus signals. So, for example, I've got an aftermarket ECU here. If I connect this to the ground of the aftermarket ECU, that's what we need to do with one of those ground pins. And then what we need to do is we need to take one of these other pins from channel 1 to 8, and we need to connect that to the CAN low cable of the CAN output of in my case the aftermarket ECU. So that's it for connection, and then obviously we want to connect the other side of the USBee AX Pro using the USB cable through to our laptop, and then we want to start up Pulseview and we'll see what we get. Okay, so you've got Pulseview installed, start it up, and this is the screen you're going to get. Now, if you've got your logic analyzer device plugged in, you should see it present up here. If you don't, there's an option to scan for it. You need to select the correct driver, and for this particular device, the USBee AX Pro, you need to select this one here, the FX2LAFW. Ours is already there, so we're good. You've got two other main control menus here. We've got this one here, which is the number of samples to collect. The more time you want to collect, then the larger the samples you need. And this here is the rate at which the samples are collected. Now, I've found through some testing that you need to seem to need 4 megahertz or higher to capture the CAN bus correctly. Below this, you start getting some real bizarre behavior. So run that at 4 megahertz or higher. Then it's a case of clicking run. Okay, so we can see there that on the D0 line we've got a range of data coming in. We're zoomed quite far out at the moment, but if we zoom in there, you'll see these are actually individual little up and downs of the signal on the CAN low. Right, now what we need to do is we need to add I like to call it a filter. I don't know what its proper name is. In here, and we'll see it's plopped it right at the bottom here. Let's try and pull that up. Here we go, can. Now if we left click on there, we've got some options. We need to tell it which channel to look at. For us it's D0, we can see all our little pulses there. And then what you'll see if we zoom out a little bit here is that the pulse view starts analysing the signal. You'll see that this bar here creeping across as it analyses the data we've captured. And then once it's all done, we'll zoom in and have a look here. Okay, so I can't be bothered waiting for it to finish the whole thing. We don't need it all. If we zoom in and have a look here, we can see we start to get some information, and we see that the pulses on the D0 channel start to line up. And on here we can see the very top line is that the actual bits, the up and down zeros or ones that we're seeing on the CAN low channel. And then on the fields here we have an interpretation of what that is. So it tells us that this particular message that's being sent out on the CAN bus here, it's got an identifier of 1000, that's in decimal, and that's correct because in the aftermarket ECU I specified to use a CAN ID of 1000, so that's correct. This next one here, the DLC, is the number of data bytes that are included in the message. Now for CAN, it's going to be somewhere between 1 and 8. And remember that the numbering starts at 0. So we can see on here, if we look, we've got a value in hex of 3 here on data byte 0 and a value of 68 on data byte 1. So those collectively, because the throttle position that I'm sending out on this aftermarket ECU at the moment is a 16-bit or 2-byte number, these two numbers get combined to present what's actually happening. Now if you've, I don't know what version of Windows it came out on, but you've got your Windows calculator and there's a programming mode in there. So let's start that up. Come on, computer. Alright, finally. Calculator. Okay, and if we go to programming mode, now we want to enter the values in hex that we've got. So in data byte 0 we've got a value of 3 in hex, which comes through as 3 in decimal. And then if we look at data byte 1, we've got a value of 68 in hex, which comes through as 104 in decimal. Now, the thing to remember here is that a value of 3 in the first data byte and data byte 0 is actually 3 times its maximum, which is 3 times 256. So if we go back to our normal calculator, we go 3 times 256, 768. We add on the 104 from data byte 1. And this gives us a value of 872. Now, this particular ECU that I'm using sends out a precision of 0.1% on the throttle position. So in this particular byte, we had the throttle position at 87.2%. And we're able to verify that by looking in the ECU and seeing its runtime values. So while it's not an elegant solution, it is a way that cheaply allows you to see what's happening on the CAN bus. And I believe that SIGROC, which is the system behind what runs this Pulseview program, is quite powerful, but I still have to explore more on how we can use that for analysing the CAN bus better.